Okay, this objective is exponential function. So the first thing I note on this one, we're just simplifying the expressions. I see parentheses so that I know I'm going to multiply. However, with the 2, we're going to have 2 to the third power, and then a to the third power, and then b to the third power, and then times, we're going to have negative 4 to the second power, a to the second power. Okay, 2 to the third power means 2 times 2 times 2, which is 8. I still have a to the 3, b to the 3, and then times negative 4 to the second means negative 4 times negative 4, which is positive 16. Your calculator might tell you otherwise. And then from here, I can multiply the normal numbers, so 16 times 8, which is 128. And then the a's I can combine by adding them, so I've got a to the 5, and then b to the third just gets to tag along for the ride. Okay, number 27, same thing. When we see parentheses, we know we're going to multiply, so I'm going to get m to the 40, n to the negative 35, p to the negative 20, and then if anything is a negative power, it belongs on the bottom, so m to the 40 gets to stay up top, but n becomes positive 35 on the bottom, and p becomes positive 20 in the numerator. Okay, 28, again we see those parentheses, so I'm going to multiply. I actually will work this two different ways in case you are a subtracting person first. If I multiplied, I'm going to get x to the 45, y to the negative 35 over x to the negative 10, y to the 15. Now, if there is a fraction bar, we are going to subtract. 45 minus negative 10 will actually be 55, and a negative 35 minus 15 will be negative 50. And then we're not allowed to have negative exponents, so my final answer will be x to the 55 or y to the 50. Now, if you'd like to subtract first, 9 minus negative 2 would be 11, and then negative 7 minus 3 would be negative 10. It's still to the 5th power, so if I multiply now, I'll get x to the 55, y to the negative 50, and then notice we end up in the same spot as the other one. Okay, number 29 says to graph y equals 0.3 to the x. Well, we know if there's an exponent in the numerator, it's an exponential function, so it's either going to grow or decay. This number is less than 1, so we know we're going to be decaying, and since there's no starting value, we're going to start at 1. So it's going to start at 1, and we just have to decay. And that's what it should look like.